Cool. Carbs. Hyperparam sweep stuff. Make sure I haven't missed anything real quick. Buffer Discord. The heck? Are you shitting me? The fuck? No. That is ridiculous. Whatever. The fuck? I don't know what the hell's going on in this Discord. I don't care. Let's see. So, right. We got to figure out a couple things with these transformations. When the mean is, when you're just sampling around the mean, it makes a lot of sense. It's really not that hard. So I think for that case, I know how to do it. You map into log or linear space, whatever, and then you rescale, so it's -1 to 1, and then you sample with, say, a 0.3 standard deviation. That will nicely cover the whole space, and then you transform back into the original space. Alternatively, you can set a custom scale per parameter. What happens when it's like, I have a sweep that I want to start at 100 million steps, that I want it to potentially get up to 10 billion steps? Does it just work? You get -1. So it kind of works. The scale parameter is a little screwy. Let me think about the scale parameter. So if you have like one standard deviation on each side, the scale param actually kind of does just work, doesn't it? So like, let's say with this entropy coefficient. This is from 0.05 to 0.0005. When we rescale this, it's going to be from -1 to 1, and the center is at 0. So with a scale of 0.5, that actually perfectly corresponds to what you would want. So I think that we are going to keep a scale param. The scale parameter is pretty much always going to be from 0 to 1, 0.2 to 1, something like that. In log space, it'll correspond nicely to orders of magnitude. Okay, I kind of like this. So let's add some stuff to this. And now the scale right, so 128, 256, 512, 124. So I think we'll do 256 as min for now. So this is a standard distribution. Scale is going to be 05. And max mean scale. One eat 8, 7, 10. 28. Or something like this. I'll make a little tool as well to plot these so you can see your distributions. And now batch size. We'll do mean. I'll make a tool to like show all the distributions. I think that'll be the best. Form. Seven. And try this. So this is it for this. Min equals 16. Okay. So this is good. Just write this is good. Okay. Now we're gonna load these params in. I'm tempted to make my own like puffer sweep thing here. I'm very tempted to make my own sweep thing here. But then I have to pass it to carbs. I guess what I'll do is I'll do it in carbs first and then we'll make our own thing. Just dehydrated. That's it. And 7. A couple hours. Maybe we just get this done today. That'd be awesome. Okay, so what we're gonna do is buffer carbs. Okay, we're gonna do min and then scale. I think we will use the scale param, but we're gonna change the way that they use the scale param. Let me just make sure. Okay, good. They don't use it in there. They only use it in utils. Let's just do it like this, right? Okay. We'll just put this up here. And we can just do quarks. So that's way easier. And now we have min, max, scale, and search center. Okay. Min, max, scale. Search center. So you don't actually get search center in the param space, which I don't like. I think param space should have a mean, or should have search center. So I think I'm going to add this. Okay. Okay, so now we have all of this stuff. So much garbage in here. Linear space. Okay, so value minus min over this. So this is 0 to 1 times 2 minus 1. Perfect. Then param from basic. Do this. And then you can round. It's fine. And pow toothpaste. Now we have mean to work with. So we don't need this. Okay, so this is 0 to 1 scaled, right? That's minus 1. Okay. And again, we're going to I'm going to use Jippity for this because I'm half asleep. I will check it, but I'm not thinking through this at this hour. Where is it? Log space. Right here. Oops. How is this different from, hold on, how is this different? Oh, I haven't done log space yet. We'll leave them like this for now, but this can get simplified a lot. It's going to take a little time. Okay. Yeah, so this is just basically the same thing. I just had to adjust the 2, the output, whatever. Okay. I'm going to remove all these round tensor and basic functions because it's literally just this for all of them. So that's going to be nice. Okay, so now we have the POW2 space. X. No clip. So now what do width do? It's almost the same, isn't it? Does the log base even matter? Does the log base even matter? It's getting scaled either way, isn't it? I think this is the exact same thing, but we'll leave it like this for now. Oh, you actually do have to round. Hold on. Yeah, hold on. So this is actually correct for yeah, this is actually correct for the log. Okay. Yeah. Maybe we will make this a little bit more reasonable. Yeah. we'll do this. I don't know why this is so hard to for the LLM. So make sure this is right. Do this. 0, 1, you multiply by 2 max, 2 min, and then you add the mean. And this is like 2 to the power of this. Rounded equals 8. It's not bad. Okay, next, log space. A little simpler. Equals. Okay. Log spaced. And then we also got to apply clips to everything, don't we? Param from basic. Maybe it does clip, who knows? We'll look at it in a bit. Let's do logic space first. Okay, so here are our spaces. We're gonna have to test them. Test carb spaces, maybe. Yeah, we can just write a quick test on these. Hmm. I'm so tired. The thing is, I don't want to write the test because I know I want to redo it in Puffer anyways. Like, I'd like to port this to be better and in Puffer. Let's see what happens if I run this now. Screw the test. We're gonna do a couple like manual checks. Long week. A lot of work. Huge amount of progress though. Okay, so um oblate. Um this is not what this line is. There's nothing there. Excuse me. Oh, this is why. Wrong freaking terminal. Wait a second. No, this is the old functions shit. So, hold on, I screwed this up. I do need to test this on the box. But I have to commit this stuff up. We're gonna have to merge some stuff because I screwed up. to merge. Very nice. Logic space. Man. Okay, so here we are. Origin samples. Search distribution in basic.sample. Is this origins in basic? Categorical dot sample origin index. Okay, origins in basic is passed in. Doesn't look to be in basic to me. Such. Basic per space to param space. Sample around origin in basic. 446. Sample search space. Origins in basic. Okay, so this is some insanity. Solve. Where the hell's this come from? By set search center. Search. Oh, okay, I think I get this. So hold on. Okay, so you get all these variables here, right? And these give you the means, the search centers. And then you do param space real basic space real. Basic from param. Okay, very nice. So we got something here. So first one is POW2 scale. Dim. From RAM of minus 508. I do not like that. Okay, so we do log 2. Zero, perfect. That's what we expect, right? Mean. Perfect. Okay. Ooh, that's not correct though. That gives you 0. Subtract the mean. You shouldn't be subtracting the mean, you should be subtracting the min. Right? Min. Now you get 0. Okay? This is what we're going to do anyways, right? Perfect. Total time steps. Does get reconstructed, but the intermediate is trash. We can see why right here. Dot log, so dot min, dot base. Here. Negative 0.33. Max. Okay, so this should not be negative 0.33. This should be at -1, I would say. Oh wait, no, hold on. The zeros are different. Maybe this is correct. 2, 3, 6, 8. Dim dot mean. Yeah, so this is potentially correct. $27, yeah, it's this. 9, 10. Okay, cool. So this is actually looking correct. Batch size, also reasonable. Mini batches, so reasonable. Learning rate, 5. Min, yeah, that's reasonable. Entropy, gamma. Gamma's no good. So let's go look at the logit space. I bet it's the same thing. Yeah, right there. Turns must be entropy. And then, okay. Hey, YouTube folks. We are currently very sleepily doing some hyperparameter space transformations in order to make this carbs hyperparam sweep algorithm way, way, way better. This would be rather exciting work if it did not come at the end of a very long week. This week started with me half dead in the hospital and ended with me like coding 12 to 14 hours a day. Shit tons of progress though. All right. What did I mess up? Math log. This looks fine to me, so let's see what's wrong. Return arrays. Oh. Math log. Yeah, there we go. I'll fix it. Still no? Oh, hold on. Same thing. Got it. Boom. Lambda and gamma are still messed up. So this logit space is still wrong. Let me see if I can see why. So you do value plus 1 over 2. And then you're going to do 0, 1 times minus min. Yeah, and then you're going to add on log of min, yeah. And then you're going to do exp. Is this wrong? Wait, this is, the reconstruction's correct. It's just the scaling is wrong somehow. Let me think. Param from basic from param. Let's see. Oh, you have to do 1 minus self min, 1 minus self max, right? Value 1 minus. There we go. So now everything is scaled. -1 to 1. You see that? I'm actually going to put an assert in there. Or a breakpoint, rather. Okay. Basic from param. We're going to do this. Where's my breakpoint? Oh. Really? Ah, this is -1. There you go. It's -1 scale. Perfect. Now we get Neptune here. Tag. Good scale. Let's see about this. There's still things to improve. So let's take a look at this here. So before, we had this plot here. Let's see what this does. And we should actually be able to debug this now. So the goal is that what was happening before is they were transforming parameters, but they weren't transforming them to like 0, 1, or -1 to 1. They were transforming them into like some weird arbitrary space. Now they're from -1 to 1. And when you sample with a standard deviation of 0.3, which is what they use, you should actually get good coverage. Now we're going to introduce variable scale soon, but for the time being, that should be pretty decent. It looks like we have an issue here. So I'll look at that. 133. Try. No breakpoint. We had it before. Round tensor in basic. Perhaps it passes tensors occasionally. Round. Maybe this was better. Let's just like to select all. There's no, I don't know where the select all is on these. Here, we'll just do this for now. Cleaned out. Okay. Let's see about this. And we'll see if we still get the warnings, and we'll see if we get better perf. Technically, if I did this out of Neptune, it would be much faster. I have to like reopen a connection every time. Wonder if there's a way to do like multiple runs without reopening it. It's just kind of annoying. It's faster than one to be at least. There's no reason that this should take like multiple seconds though. It should be done in like a quarter of a second. Okay, so I mean, we can start looking at these a little bit. This is getting good samples from what's this, 32 down to 8, so it's getting some samples. Update epochs up to 2, it gets some samples there. And is good. Numems, I think I forgot to configure. Doesn't really matter though. Mini batches, not really getting any samples. Is total time steps going up? We'll see. Hold on. Doesn't define round method. Okay. What's an easy way to round a tensor that'll also work on the other stuff? What's a good way to do that? I mean, I see this round here. Tensor doesn't define round. Let me look at what the original did. How'd they do their rounding? They do round. Oh, I see. Is integer and is rounded. Oh, I see. Round, tensor, and basic. Yeah, okay. So this is torch.round. This is why they did this. That's obnoxious, though. Okay, we'll think about that later. That's super obnoxious. For now, I'm going to do For now, I'm going to do this. Let's hope that that does it. Let's see. See if this is enough. I'm tired. This is gonna be, I think I got maybe an hour left in me tops. Seems like this is running. Maybe that was enough. It's a stupid for loop, but I'm gonna end up rewriting most of carbs. Once I get it, once I'm like really happy with the performance of carbs, I'll put some effort in to make sure that it's nice and clean, like really easy to understand and use. Ah, god damn it! I thought that this was good. Let me see. Round tensor and basic. That sucks. You know what we're gonna do? I'll tell you what, we're gonna do something silly. We'll just do if is instance log spaced int tensor. Okay, we're gonna just do that. And the rest of it doesn't have rounding. I guess this one does. We don't use this thing at all. So if I think this is good enough. I just want to get this thing working today and see the graph actually do what I expect it to do, you know? Come on, Neptune. Okay, so we'll see in a bit if this is correct or not. At 79, it's better than any of the runs we had before already. It's promising. The code's just really janky the way they do their spaces. I think probably what we're going to do is I'm going to design like a puffer spaces thing. It's going to be pretty similar, it's just going to be cleaner. And then I'll like make carbs use those or something. Seriously? Assertion error. Okay. Oh, yeah, because it's a tensor, right? These asserts are like, I don't know why it passes tensors, to be honest. We'll catch the values being screwy from other things. Man, good work week. This is one of the more productive work weeks I've had on the books. Did like major stuff for 2 different labs, 2 different clients, science side here, reviewed several thousand lines of code for Puffer. Good progress. If I just do this every week, RL will be solved in like 6 months. It's a crazy pace. Okay. Oh, cool update. Heck. Seriously, still, are you kidding me? I guess this actually needs to have a freaking round tensor in basic. Fine, I'll just implement it. This doesn't get rounded. Let's see if this is actually needed. I don't know if you actually need to round it like that. That seems weird. Let's try this as a quick thing. Okay, how do you just highlight all the boxes? I know I can do this, but then it doesn't always go immediately. We're going to do this. Okay, so hopefully this one works. So what I've done here, I've rescaled the hyperparameters into a negative one-to-one space, either linear or logarithmic, depending on the parameter. And then sampling and prediction is done in that space. So not only should it be easier to learn a model in that space, but now the sampling should correctly be, it should be sampling values on a reasonable scale, which should make it easier for carbs to learn to shift over to better parameters over time. Originally, the algorithm, it made it like if you had good initial parameters, it could find stuff nearby. But I think this will make it able to drift over to the better parameters more effectively. If I have it correct. We will see. This is actually going to be incredibly big for RL once I get this working. This is a synthetic benchmark that I have at the moment. I know exactly how well it should do on this benchmark. And pretty much as soon as we hit the number, I will be confident in this implementation, and this should just shred any and all RL environments. And basically, it will be so good that we'll be confident that if it doesn't solve the environment, something else is wrong. And we'll actually be able to do really nice analysis off of that. Okay, so here is, it should start improving over time. It doesn't fail right here. Okay, good. So it no longer is failing. Oh, look at that. Great. Figuring out batch size. Not figuring out total time steps is a bit concerning. Mini batches figured out. Figuring out gamma, lambda. Hasn't figured out update epochs yet. A few other things. We shall see. Oh, perfect. So this is already better, way better than before. Now, whether this is actually going to full solve, we'll see. This is progress. There you go. So it's figured out this batch size parameter already. I'm a little concerned with the total time steps. It doesn't seem it's figured this out yet. I don't think I have the cost component in, so it should just figure this out. And learning rate as well. Oh, no, it's figuring out learning rate. 9, yep. 5, okay, it's figuring that out. Update epochs, for some reason it's not figuring out yet. It could be a sampling issue. Okay, so it's gotten up to 95. It's better than before. Definitely better than before. I think there's still going to be some space issues that we're going to have to fix. Under-generated. Okay, that's fine. I generated 816 samples. I wonder if I could just rewrite most of the carbs code tomorrow. At least like the sampling portion. It's very confusing the way it is at the moment. The only thing I'm not positive is like, I mean, intuitively, it seems like carbs really should be the algorithm to go to. It has everything you'd want. paper at least. I'm pretty sure I could solve this benchmark with the genetic algorithm, though, right here. Like, better. But I assume that carbs just isn't properly set up yet, because the carbs really should be better. Okay, so this is getting better. Look at this. Maybe it's starting to figure out the time steps. The batch size, many batches. Learning rate is now almost figured out. Gamma, I believe, is supposed to be 0.99. It's around that area. 9.5 for lambda. Yeah, that's good. Oh, look, it just sampled update epochs. So this is probably a sample issue with the spacing. Let's figure this out. I don't know why it hasn't figured out BPT horizon. This should be 16. Also possible a sample thing. And numems doesn't matter, so it's allowed to drift. Yeah, this is way better than before already, though. And you can actually see total time steps starting to recover. I don't know why it went down this far in the first place, is the only thing. There should have been a pretty darn clear signal for this. It's only gotten 40 runs, though, and it's already to 150. I believe 250 or so is the max. That requires you to max out all the scale parameters and then tightly fit the remaining hyperparameters. But this is the type of curve that we want. Right? The algorithm should clearly just get better over time. Oh yeah, there you go. So there's batch size starting to get sampled. 150. Update epochs is still at 2. I guess it's just a big jump, is all. It's a big jump. Could be similar over here with these power ones. I mean, this is a massive improvement, though, over what we had before. To give you an idea, like, I think we had this. Yeah, so this was 140 runs, same exact task. You can see how slowly it was starting to like get the time steps back. This is because the sample spaces were screwed up. Sample spaces screwed up, couldn't find a better batch size. You know, it would fit like these parameters pretty nicely. But that was about it. So this is a massive, massive improvement. And this should translate to real tasks as well. Okay, up to 180, and you can see, I don't know why total time steps went down here to begin with. It really should have latched on to these points here. But it does recover. Batch size is fixed, mini batch is fixed. Learning rate is basically to where it should be. 001, I believe, is the optimal. So it's getting pretty well there. It's not really tightly fitting them is the only thing. It's not tightly fitting these parameters quite yet. I would like it to have a tighter fit. I guess technically it won't have a tighter fit, though, because yeah, an artifact of the sampling at the moment is it samples pretty widely around the Pareto bounds because it's generating candidates and then scoring them. I might have to look at that. I might have to look at that. Yeah, this is why this is so noisy, okay. And there you go, update epoch. So the bounds are not amazing here, but you can see it is getting there eventually. PPT horizon seems stuck, but whatever. For the most part, these are actually, they're getting it now. And there we're up to 180 something. 57 runs. Okay. This is a good result. This is a good result. It's not quite perfect yet. We're going to still have to tune some things, but it is definitely getting there. I think realistically, you should be able to get, within 50 runs, you should be able to have it mostly solved. Because, so all these parameters are independent. You should be able to tease that out of the model very quickly. You shouldn't waste time doing this. With better sampling, you should get this more quickly. This is pretty good already. Mini batches kind of worked. You should get tighter bounds on these parameters more quickly with more sample gen. These as well. And then this update epochs and BPT horizon, this is scale issue. You can see that it does get up to 4 here, so it's good. And then numems doesn't matter for this test. This is pretty much doing what I would want. The only thing is, I guess the total time steps can't really move as quickly as you'd want it to. I mean, we'll have to look at some stuff with that. Yeah. Okay, 180. Not just full solving. It's still not full solving it. But we're starting to get these time steps way up here. Yeah. Okay, I'm satisfied with this. It's a good result. It's not perfect. We'll finish the rest of this, I think, tomorrow. I'm pretty tired. Just like to get some sleep. Carb stuff will be good soon. Let me just make sure there's not anything important. No, nothing. Okay. I think tomorrow is going to be the day we have a solid hyperparam algorithm for RL finally. It'll be really nice. It's kind of plateaued here. It needs to be able to make more aggressive steps on stuff like this. It has 60 something data points. It should be very confident that there is a clear correlation between more time steps and more perf based on this test. I might also take this out of Neptune so we can run these way faster. This is kind of silly how long this is taking for these. Yeah. I mean, that's more than double the perf from before, so that's a good start just from fixing some space transforms. All right, I'm kind of dallying here. I should just go get some sleep and then start nice and reasonable in the morning. Get a good full day in tomorrow on this. There are a bunch of other projects to work on, but I think that this one is going to be worth investing tomorrow into. If we can really get a nice solid carbs thing packaged up for Puffer, this will just I mean, this will be like a several-fold improvement to PufferLib, just overnight. Because if you think about it, this just makes all your experiments better and faster. I mean, heck, I don't even think we'll have to do early stopping if we get this to work well enough, because carbs will just do that for you. Yeah. Okay. Well, all this stuff is free and open source. So if you want to learn more about any of this stuff, it is on puffer.ai. You can start the repository on GitHub. That really helps me out a ton. It's free to do. You can join 900 people in our Discord, building RL environments and doing cool stuff. And follow me on X, where I post a bunch of RL things. A lot of articles on here as well. There's a blog with lots of nice RL resources here. And we've got docs. We've got demos of all of our environments. We've got all sorts of fun goodies here. So join up if you're interested. I review contributed environments live on stream if you're interested in building some of those. Other than that, I'm going to call it a night.